Let's see the concept of RAID, redundant array of inexpensive disk or independent disk. Okay, so it is also called redundant array of inexpensive disk or independent disk. The meaning of redundant means duplication. The meaning of redundant means duplication. Array means a set of independent disk. Okay, a set of independent disk. That means these writes are used for higher reliability and higher data transfer rates. Okay, so here we'll maintain some disk, redundant disk, data duplication will be done here. Okay, why we are using this particular writes? Because writes are implemented on magnetic disk, they are cheaper, they are getting cheaper, cheaper as so. And these disk drives, the size of the disk drives are getting smaller and the cost is also getting cheaper. So it is feasible, economically feasible to store the data, that is data in a disk drives, data in a disk drives, because whenever there is a natural disasters will happen, there's like cyclones or earthquakes will be happen, the data will be lost, data at one place will be lost. The concept of RAID is that we can store this particular data in some other place. We can store this particular data in some other place so that the data that can be lost here, we can recover the data from some other place. Okay, so there are several techniques how to recover the lost data and how to give the user to the data that is permanent, that is how to store the data and how to recover the data. There are different techniques in RAID. Okay, so one more thing, that if you maintain the data in two different places, okay, so that we can run this particular two disk parallelly, so that user 1 will request and user 2 will request, okay, some particular data. Because the data is present in two different disks, data is present in two different disks, the advantage is that we can send the data from user 1 to this particular disk and some to this particular disk. Okay, so there are different types of benefits, different benefits will be there. The data will be the major advantages are, uh, first one, reliability and high data the object major objective is we need reliability, high data transfer rate, and the data should be available to the user, the data should be available to the user. So availability is also one objective in this particular by using this particular rights. Okay, so the major concept is if one disk is failed, we cannot lost the entire data. Okay, so we can recover the data even though a disk has been failed. So there are different levels of writes are there. First one, write 0, write 1, write 2, write 3, write 4, write 5, write 6, followed by write 0 plus 1 and 1 plus 0. Okay, so let's see one by one what is meant by write 0 and write 1. First, write 0. Write 0 here, it is called non-redundant striping. That means the data is not duplicated here. The data is not duplicated here. But what is actually happened? Instead of storing the entire data into one disk, we will divide the data, okay, and put it onto different disks. That means the entire data will be divided. That means if there is some amount of memory will be there, that particular amount of data will be divided into different parts. Each part will be stored on separate disks. Okay, so some part of the data is stored on one disk and other part of the data is stored onto other disk without duplication. Here duplication is not work. So if something is happened to this particular device, the data that is available in this particular device will not be affected. Only the data that is present in this particular device will be lost. Okay, so next one will be disk mirroring. Next one will be disk mirroring. In disk mirroring, for each and every disk, there is a backup disk. There is a backup disk. Okay, that means the data that is stored in this particular disk will maintain the copy of one more disk. Okay, so if it is D1, D2, D3, D3, disk 1, disk 2, disk 3, disk 4. This is copy of disk 1, copy of disk 2, copy of disk 3, copy of disk 4. The entire data will be copied to C1. The D2 will be copied to C2. D3 will be copied to C3 and D4 will be copied to C4. That's why it is called mirroring. That's why it is called mirroring. This is used for backup purpose. This is used for backup purpose. So even though disk 1 is failed, okay, or disk 1 is failed, we can recover the data from C1, the backup copy of disk, backup disk. But if D1 and C1 both are fails, then there is a problem of recovering the data. We cannot recover the data of both D1 and C1, but it's a rare possibility. It's a rare possibility. But when you take the capacity of this one, we can only use 50% of entire capacity, because for one particular data, we need one more disk. That means if 4 disks are there, we need to use 8 disks. We need to use 8 disks. But we can guarantee the reliability of data. We can guarantee the reliability of data. That means one disk reliability and also availability. Also availability. What is mean by this one? If one disk is failed, still we can recover the data. And if any user asked that, okay, any user request the data, the servers can transfer the data from the backup disk. Okay, once this disk is replaced by new disk, okay, disk is replaced by new disk, then whatever the data that is present in the backup disk C1, C2, C3, C4, we can transfer the entire data to new disk, entire data to new disk. Okay, so that is called mirroring. Striving means dividing the data into different parts and each part will be stored onto different disk. But mirroring means we will copy the entire data in the disk 1 and copied it into one more disk. Okay, so next one, in write to, it is different from 0 and 1. It is different from 0 and 1. In write to, we use error correcting codes. We use error correcting codes instead of maintaining a separate disk for the recovery redundancy purpose. Here we will use error correcting codes with the concept of even parity and odd parity. Even parity and odd parity. Okay, so if there is any error in the disk, if there is any errors in the disk, those errors will be identified by this particular parity bits. Okay, so here for each byte, you remember this particular statement, because write level 2, level 3, level 4, level 5 are having very thin difference. Here we'll maintain for each byte in a memory system, we have to find an even parity or odd parity. That means if there are 8 bits, 1 0 1 0 1 1 0 1 1 1 0 1, so how many ones are there? 1 2 3 4 5. 1 2 3 4 5. So to make this one as even parity, we need to add 1 here. Okay, so this one, so total number of ones will be, you need to add 1, so it will become even parity. Okay, if there are odd number of 1 1 0 1 1 1 1 1 0, so 1 2 3 4 5 6, so it is satisfying the even parity. So you need to take 0 as the computed parity, 0 as the computed parity. Okay, so this computed parity will be this one, and we need to find the compute the parity bit. Okay, we need to compute the parity bit. Now if you read the data from the disk, okay, and we need to make sure that whether the data is correct or corrupt, correct or corrupt, or if the data is corrupt. If the data is corrupt, we can decide by using this particular parity bits. Okay, but using this particular even and parity and odd parity, we can only identify one bit error. We can only identify one bit error. When there are multiple bits of errors are there, this particular even parity or odd parity is unable to find whether the data is correct or correct. But it makes sure that if there is a one bit error, it guarantees that the data is corrupted, because because if you want to read the data, you need to compute this particular parity bit. If the computed parity is equals to your stored parity, computed parity is equals to stored parity, okay, then your data is correct. If the computer parity is not equal to stored parity, then your data that is correct. Okay, right here for 4 disks we need 3 parity disks. For 4 disks we need 3 parity disks. Okay, so the first bit of each byte can be stored on disk 1. The second bit is stored in disk 2, and so on until the 8th bit is stored in disk 8. Until the stored in disk 8. So the error correction bits are stored in further disk. So if you take a byte, we can store one bit in one disk, one bit in one disk. Okay, so if any one of the disk fails with the remaining bits of the byte, okay, remaining bits of the byte, by that is if total 8 bits that is stored on 8 disk, if any one of the disk is failed, then there is chance of only one bit error. There is only chance of one bit error, that is lost for each byte. One bit for one byte will be lost. One bit for each byte, there is one bit will. So how to recover this particular one bit? By taking the bits from parity bits, because whatever for each byte we will compute the parity bit and store it on the parity disk. Store it on the parity disk. Suppose that if 7 bits are there, okay, by using even parity and odd parity. Suppose that 1 0 1 1 0011. So all the bits are stored in different disks. All the bits are stored in different disks. Suppose that this one is lost. So what is the computer stored parity? 1 2 3 4 5. There are 5 to make it even. This will be 1. So if this is lost, by using this one, so 1 2 3 4, and this one is 5, this one is 5, we are maintaining even parity. So system will compute that there should be a 1 should be here, there should be a 1 should be here, so that it will be 1 2 3 4 5, which will make odd, okay, odd number of ones. So it is 1, we can add 1 here. If it is 0, you can add 0 here. Okay, so that's how write level 2 works. Write level 2 works. Then the difference between write level 2 and level 3 is that here instead of each byte we'll maintain, okay, so we'll maintain a parity bit for a sector. We'll maintain a parity bit for sector. A sector is a combination of different bytes, set of bytes. Okay, the size of the sector that will be defined by your operating system or your hardware, operating system, your hardware disk. Okay, so here we'll compute a single parity bit for each sector. We'll compute single parity bits for each sector. While if if a sector is damaged, then we know exactly which sector will be damaged, exactly which sector will be damaged, and we can able to correct the data, we can able to correct the corrupted data, okay, by using the parity disk. So here for 4 disk we'll maintain one complete disk for the purpose of parity, for the purpose of parity. So this particular disk is purely dedicated to parity bits, purely dedicated to parity bits. So if there is any problem with reading any sector, okay, we can compute, we can recover the corrupted data by using this particular parity. Okay, so in write level 2 we need, for 4 disks we need 3 parity disks, but when it comes to a sector, sector parity, okay, that is block level, block interlude bit interlude parity, that is write level 3. Here for 4 disks we need only one extra parity disk. Okay, so write level 2 the parity will be computed for byte, write level 3 the parity will be computed for sector, and write level 4 the parity will be computed for a complete block. Okay, right, it is a block level parity, it is a block level parity. Okay, so it uses block level striping, block level striping, and keeps the data, keeps the parity block on a separate disk. Again it is on a separate disk. Okay, so there is a small difference, minor difference. Write level 2 which is for 1 byte, write level 3 which is for block. Okay, so that is sector, sorry, a sector. And write level 4 we'll compute the parity bit for a complete block, a complete block. Okay, so if any one of the disk will be failed, okay, the parity block can be used for the corresponding blocks from the other disk and restore the blocks of the failed disk, restore the blocks of failed disk. The same concept that will be applied for write level 2, level 3, level 4. But here also, as similar to write level 3, write level 4 will also use one complete parity bit, but the parity is computed for blocks, block of data. Parity is computed for a block of data. Okay, then write level 5, right, level 5 which is similar to write level 4, but here along with the data, okay, along with the data we are not maintaining a separate parity disk, we are not maintaining a separate parity disk. Along with the data, the parity bits will also be, the parity will also be striped into different disks, striped into different disk. But how it will be done? Let us take 1, 2, 3, 4, 5. Okay, so this the data will be striped into these 4 disks. The data will be striped into these, that is 1, 2, 3, 4. Then the computed parity will be stored, these 4 disk parity will be stored into 5. That means the uh, let us take an array of 5 disks, 1, 2, 3, 4, 5. The parity of the nth block, the parity of nth block is stored on n plus n modulo 5 plus 1. Okay, so let us take 0, 1, 2, because computers calculates from 0. Okay, the value starts from 0. So disk 0 parity is stored on disk 1. Disk 1 parities will be stored on disk 2. Disk 2 parities will be stored on disk 3. Disk 3 parity will be stored on disk 4. That means if any one of the disk will be failed, based on the parities is not stored on the same disk, the parity is stored on the next disk, the corresponding next disk. So from this particular disk, so if 2 is failed, the data that we can recover from the parity bits that are stored in 3, the parity bits that are stored in 3. If a 3 will be failed, the parity bits stored in 4. So by using 4 parity bits, parity data, we can recover the data of disk 3. Okay, right? So the most commonly used write system is your write level 5, which is the most commonly used write level. Okay, then next one is write P plus Q, right? P plus Q. Until now, we are only consider one disk failure. Until now, we are only consider one disk failure. If multiple disks are failed, then entire write level 2, level 3, level 4, level 5, the data will be lost. We lost the data if multiple disks are failed. So that means if two disks are failed, we are only uh, consider about one disk failure. If two disk failures are happen, then write level 2, 3, write 0 to write 1 to write 5. They cannot recover the extra disk that is uh, damaged. Okay, that is failed. So in order to uh, cope up with, in order to maintain the data, that means recover the data, if two disk failures are happen, if two disk failures are happen, we'll go with write 6, that is write P plus Q. Okay, so here instead of one parity, we will use two parities. We will use two parities. Okay, so it is like write level 5, but store the extra redundant information to guard against multiple disk failures. Okay, so instead here instead of even parity and odd parity, because that can only recover one bit, that one bit data. Okay, one bit loss of data or one bit recover. Here we can use Reed Solomon codes. Here we can use Reed Solomon codes instead of even parity and odd parity. So 2 bits of redundant data are stored for every 4 bits of data. For every 4 bits of data. So it is compared with 1 parity bit and level 5. Okay. So 2 bits of redundant data will be stored for 4 bits of data. 4 bits of data. So these two parity bits can able to recover two disk failures. Can able to recover two disk failures. And next it will be write 0 plus 1 and 1 plus 0. Write 0 plus 1 and 1 plus 0. See, we can say that write 0 is striping. Write 0 is striping. That is dividing the data into different different disks. We're dividing our data into different disks so that it is faster. When accessing this one, it is faster. The performance will be increased in striping. But reliability and availability is increased in write 1. Write 1. So what will happen in write 0 plus 1 and 1 plus 0? Which one will happen? Striping will be happen and mirroring will be. Now in write 0 plus 1, first the data will be striped. The data will be striped. That means that the entire data is divided into different parts and each part is distributed into different disk. Okay. Then that particular striped data will be mirror. Will be mirror. That means if the partitions of data is stored onto different disk and this particular disk data is copied to one more disk, is copied to one more disk. This is called what is write 0 plus 1. When it comes to write 1 plus 0, first we will maintain the mirror. Okay, so x will be there, suppose disk 1 and disk 2 and disk 3 and disk 4. Okay, so what we will do, first we will mirror the data, Then we'll distribute the data into different ways. We'll distribute the data into different disk. Okay, so the data will be mirrored and distributed into different disk, other disk. Okay, so write 0 plus 1 first, write, then mirror. In write 1 plus 0 first, the data will be duplicated, then the duplicated data will be copied to different disks. Okay, so that's it.